Today's subject is limiting reactants, and I've got some visual aids here. We have a compound that looks like a bolt, a compound that looks like a washer, and a compound that looks like a nut. And these all react together to form a new compound that looks like this. It's got a nut, a bolt, and a washer on it. Now, we've been acting like when we do a reaction that we have just the right amount of everything. But in real life, we're more likely to have kind of a mess of reactants. And when we go to make our compounds, I can make a second one, and I can make a third one. Oh, I'm missing that. I can make a third one, but I can't make a fourth one because I'm running out of the washers. Oh, there we go. All right. So the washer is the limiting reactant because we have that left over. We could make more of our compound if only we had more washers. Limiting reaction is the washer, and that's because we ran out. The excess reagent or excess reactant are the nuts and the bolts. And that's because we have those left over. So our limiting reactant is the one that's completely used up. And it limits the amount of product. The excess reactant is the one that has some left over. Yeah, so we can calculate the moles of product that can be made from the limiting reactant. So let's look at this problem. If we have 3 moles of carbon monoxide and 5 moles of hydrogen, how many moles of methanol can be produced, and what is the limiting reactant? What is the mass of methanol formed? Okay, so this is our equation. We've got 1 carbon monoxide and 2 hydrogens make 1 methane. In the problem, we're told that we have 3 moles of CO2, CO, and we have 5 moles of hydrogen. What we're going to do is we're going to write out 2 reactions. One, if all of the carbon, let's pick a different color, if all of the carbon monoxide reacts, we'll have 3 times this reaction. So this is written for 1 mole of carbon monoxide, but we've got 3 moles of carbon monoxide to react. So we're going to multiply our 1 by 3 to get 3. So if we multiply that, we have to multiply all of them, and we get 6 moles of hydrogen. So 3 moles of carbon monoxide will react with 6 moles of hydrogen and produce 3 moles of methane. Okay, so what's written in black is what the problem tells us. The calculations are what I've put in. So let's pick a different color. Hopefully this red will be different enough. If I have 5 moles of hydrogen and they all react, I've multiplied this equation by 2.5. 2.5 times 2 gives me 5. Okay, so if all of the hydrogen is going to react, we would multiply everything by 2.5. Okay, so we'd need 2.5 moles of the carbon monoxide, and we'd make 2.5 moles of the methanol. Now, both of these conditions aren't going to happen, because what's going to really happen is the carbon monoxide will start to react, but we only have 5 moles of it. For all the carbon monoxide to react, we need 6 moles of the hydrogen. We don't have 6 moles of hydrogen. So we only have 5. So this is going to be our limiting reactant. And this is not going to occur. The other way you can look at this is you can see if all the carbon monoxide reacts, we make 3 moles of our product. If all of the hydrogen reacts, we make 2.5. So we only have enough hydrogen to make 2.5 moles. We can only make 2.5 moles. So this will be our product. Okay. So let's do it. What is the mass of methanol formed? If I have 2.5 moles of methanol, that's the abbreviation for methanol, we'll need the molar mass of methanol. Methanol consists of a carbon, which is 12.01 grams, plus 4 hydrogens, 1.008 grams, and an oxygen. And that adds up to, that worked out, 32.038 grams. And that's the molar mass, so we've put 1 mole of methanol, 32.038 grams of methanol, and that gives us an answer of 80.1 grams. Okay, let's look at the same reaction, but we have different amounts of the reagents present. So in this reaction, we've got 4 moles of each reagent. Notice here that we're dealing in moles, not grams. Whenever we deal with a balanced chemical reaction like this, we need to be in moles. So we've got 4 moles of carbon monoxide. We also have 4 moles of hydrogen. Okay, so this is, we'll have to keep the same colors. To get from 1 to 4, we're going to multiply by 4. What we do to the carbon monoxide, we need to do to the hydrogen. So 4 moles of carbon monoxide will react with 8 moles of hydrogen. Do we have 8 moles of hydrogen? No, we do not. We have 4 moles of hydrogen. So this is not going to happen. So we look here. We've got, to get to here, we had to multiply 2 times 2 gives us 4. What we do to hydrogen, we have to do to the carbon monoxide. So 4 moles of hydrogen will react with 2 moles of carbon monoxide. Do we have 2 moles of carbon monoxide? Yes, we do. We've got actually 4 moles, so we've got more carbon monoxide than we need. So again, the hydrogen is limiting. And we will make 2 moles of methanol. And as limiting reaction in grams of methanol, we can take our 2 moles of methanol The molar mass is not changed. It's still 32.038 grams, 1 mole. And so here are some other terms that you will hear in chemistry. One is the theoretical yield. The theoretical yield is the amount of product that could be made if all the reactant was converted into product with no losses. So the theoretical yield is something that happens only in an ideal world, because we always have a few side reactions occurring, and we get some of our product will be stuck to the glassware or lost in a filter. So the amount of product, the theoretical yield, is a ideal world sort of thing. The actual yield is the amount of product that is actually recovered. It's always going to be less than the theoretical yield because some loss is unavoidable. The percent yield is determined by taking the actual yield and dividing it by the theoretical yield. So in the problem below, if I calculated that an experiment should yield 12.89 grams, but I only got 8.51 grams, what is the percent yield? Well, we'll use this equation that's right above, and we'll say that our percent yield is equal to the actual divided by the theoretical. The amount that I calculated is going to be our theoretical, 12.89, and we'll put our actual, what you really got, above it. 0.51, these are both in grams. We have to multiply it times 100% to make it a percentage, and we'll get a recovery of 87. So we get our final answer of 66.0%.